Understood.
Okay. Stretching. All right. Next one. This is a frequency table. Okay. And if you're asked for probability from a frequency table, then you need to probably extend it into a relative frequency table. So, because frequencies don't give you probabilities, but relative frequencies give you percentages and, proportions. So I'm going to extend it to a relative frequency distribution table, but I need to know how many total people were in this group first. And so in order to do that, I have to add up my frequency column. So 66 plus 64 plus 69 plus 54 plus 93 plus 99. Okay, check my numbers, 445. You can check my numbers. And actually, use some notation. The sum of my frequency column is 445. The sum of this column is 445. You check my numbers. So I'm claiming there's 445 total customers. The store manager gathers some demographic information from the store's customers. The following chart summarizes the age-related information they collected. So 66 customers are less than 20. 64 customers are between 20 and 29 inclusive. 69 customers are between 30 and 39 inclusive. So the majority of their customers are how old? How old are the majority of their customers?
Over 60.
Yeah, so I don't know what kind of store this is, but the majority of the customers are over 60. I mean, significant, right? So let's talk about the relative frequencies, which are going to give me, percentages if I want it in percentage form or decimal form. We'll leave it in decimal form because typically our probabilities are being asked to round, right? Round to 4 decimal places. So if I ask you, well, if 66 customers are less than 20 years old, what's the relative frequency of that? Or what proportion of customers are less than 20? Well, 66 out of the total 445 are less than 20, right? 66 out of the total 445. I'm finding the relative frequency for that particular class, if you remember the terms from back in the day when we did the frequency table. 0.1483, approximately 0.1483. Check my numbers. This is the relative frequency, also known as the proportion of customers that were, less than 20. Now, I'm only going to find it for each one of these because I might ask random questions about each one. So the relative frequency for the second class, or the number of customers that were between 20 and 29 inclusive, 64, right? And then I'm going to write this real fast. So I'm going to be doing this for each one, and you guys go ahead of me and do them so you can check my numbers because I'm going to do it fast. I'm going to show you why I don't necessarily have to do it for every single one, depending on what questions are asked me, but because I might randomly make up some stuff too, then I might need all these anyway. So 64 out of 445 is 0.1438. 0.1438. 69 out of 445. Oops. Is 0.1551. Grab your calculator. 54 out of 445. 0.1213.
You are super fast. Like, I can't even, like, this calculator is like the death of me. I'm like, oh wait, I made a mistake, but how do I go back?
Grab your calculator. Listen, I'll let it sit on it for a second too. We'll 93 out of, sometimes I get excited and I move, I go, psh. And then 99. I'm going to check it by adding them all up too, by the way. 0.28, oh, see? 0.2225. This one, 0.209. Okay.
And I guess that's what's cool about this calculator, because it keeps it stored in there, so then we can just select all of them.
Mm-hmm. So if I want to check, I can go up to the first one, which was this one, 66, and I'm going to add them up. This one plus, if you want to do it that way, or I could straight up go here too. Whatever. 0.1483. Whatever you choose. 0.14.
Well, isn't there a spot on the calculator where you could just take that whole row and add them? No.
You mean the column?
Yeah, like, no, you can't do that with when
No, no. You can only take the very last number, not all of them. The very last one. Oops, I think I messed up. Go figure. 0.1483. I'm just, this is just to verify that it adds up to 1. That's just to make sure I didn't make an error, but, not necessarily required, just me double checking while you guys check my numbers too. Should be 1. This is exactly 1. So my rounding is beautiful.
Good job.
Beautiful rounding. So I'm assuming my calculations are accurate. All right. Let me make up some questions. You can continue to check that while I
check it. You're great.
Yes. Okay, cool. So, okay. If
I just want you to know, if I don't hop on tutoring at least one day a week, I am completely lost when it comes to homework.
Yeah, well, probability can be, its own little battle. If I only choose one customer, and I get how it feels too, because you guys go from terms to, means and some graphs and then probability, bam. So I do get it. It's like you get hit with probability. Yeah. And next week we're doing more probability, but it's a different special type of probability. Okay, if I randomly choose one customer at random, right? What is the probability? So this is kind of number 7, right? That the customer is, let's just do at least 40, at least 40. So there, I randomly choose one customer. What is the probability that the customer is at least 40 years old? So, well, at least 40 means 40 or more. Well, how many people are 40 or more? So you could do this 2 different ways, okay? We already found our frequencies, which I wanted to do because when you guys get into probability distribution tables, which are next week, you won't have the frequencies. You'll already have the relative frequencies done. So you'd be answering these type of questions with like a relative frequency table in front of you. But you don't necessarily have to calculate all these to calculate this either. I'll show you kind of both ways. If I randomly choose one customer, what is the probability that they're at least 40? Well, at least 40 means 40 or more. And that includes these 3 classes. Now, being that I already calculated the probabilities or the relative frequencies for each of them, all I have to do is add up those corresponding relative frequencies. Because technically, this is the probability for this. This is the probability for this.
Which is, oh, sorry.
Go ahead. At least 40 includes all of them, so I'm just adding them up. Go ahead. What was your question?
No, I was gonna say 1, but it was 40 and up.
Yeah. Well, if it was at least 0, or less than or equal to 60, then that we would say, ah, it's a certain event. We're including everybody, but I'm not including everyone. Just at least 40. Which is, I don't know, what is that? 0.1213 plus 0.209 plus 0.2225, which is 0.5528. Okay. Now, the reason that I said that you don't necessarily have to do this first is because you could potentially add up the 54, the 93, the 99, and do that total out of 445 and get the same, right? 54 plus 93 plus 99 out of 445. Get the same thing. The only reason, like I said, I did this is to not only compare to what you learned with relative frequencies, but when you do get to a probability distribution table, it is very much like a relative frequency table, and you could potentially be asked similar questions, just not with frequencies, with relative frequencies instead. They might not be called relative frequencies, they might be called probabilities. So just to show you both scenarios, okay? It's kind of what I'm doing here. It doesn't look like you're selecting more than one for this table either. If I'm really randomly choosing one customer again, what is the probability that they are less than 20 or at least 60? Well, less than 20 includes the first, which I already calculated that probability for. Or at least 60 means 60 or more. That's the last class, which I already calculated the probability for. 0.1483 plus 0.2225. I keep forgetting that. There's 3 2's in that. 0.3708. Again, if I were not doing, or if I didn't have the relative frequencies of each, I would say, well, there's 66 less than 20, and there's 99 greater than or equal to 60. So 66 plus 99 out of the total 445. Same thing, right? So, I mean, in a sense, it's a little bit easier than what you've actually been doing, right? Because just like adding up. The reason that, again, a reason that I wanted to show it this particular way is because you could be asked in a lot of different ways. Actually, I'm going to add one more real quick question, but this is, you'll hear this terminology later, probability distribution table, because, you know, you have all the possible outcomes and their corresponding probabilities or relative frequencies. So you might see another table later on, same idea, again, with the relative frequencies, asking the same type of questions. Okay, let's do this one. 2 ways to do this, okay? And I want to show you both of these because complementary events allow us to sometimes make our calculations a little bit faster, right? And this is an example of where complementary events might do that. So let me show you what I mean. When I say a customer is at least 20, and I'm only choosing one, 20 or more. So that's basically all of these. That's all of these. That's all of these, which I would have to add up. So I'll write that out. That's the 0.1438 plus the 0.155. This because this is for your notes. 1 plus the 0.1213 plus the 0.209 and all that good stuff, right? But you know, there's a faster way to do that. What's the complement of that? You know, the complement of something is everything but that something. So if I say at least 20, that's 20 or more, that's all it is. The complement of that is this guy by himself, right? Because obviously complementary events have to come together to be the whole sample space. So the reason that I'm claiming that this is easier is because all I would have to do is subtract its complement from 1, and I get the same number either way. So either I can add up all these to get that total, or I can say, well, if the sum of all of these is 1, if I subtract this from 1, then I'll get the rest of them already added together. And you can verify that. 1 minus 0.14883, 0.8517. Get really good with complementary events because it's going to help you when you get into stuff that's coming. Complementary events are going to make our lives easier because obviously it can decrease the time spent with calculation. Okay.
How we find cluster?
A what?
How we find cluster if we have age and relative frequency and we don't have cluster, number of cluster.
Are you saying, what are you saying? Cluster?
Yes. What is this? This is 66, 64, 69, 54. How we find that one?
These values?
Yes.
They're given to you.
Oh, customer.
Yeah,
Number
yeah.
of customer. Okay, so that
Yes.
that one is given to us. Okay.
This is given to you. I found this. You could potentially, like I said, get away without, you know, finding the relative frequencies for each, because obviously you can do the probabilities based on these values. But the reason that I showed it with the relative frequencies is because of the fact that you're going to get into probability distribution tables, which are coming, which deal with, you know, more so relative frequencies. Basically, everything's already calculated for you, which is nice. Makes it a little bit easier. So, but all of these things are fair game. At least this, at least that, greater than, you know, less than. And then sometimes complementary events allow our calculations to be a little bit faster. So I wanted to just show at least one of those, because you'll get into the situation where complementary events, you're going to want to use complements to calculate instead of, you know,
I see.
Going through a longer process. Wait, let me stop recording. And